Hello friends, in this video we'll discuss the formation of image in a concave and a convex mirror. In the first video we have discussed the reflection formation of image in a plane mirror, then different terms associated with spherical mirrors, that is concave mirror and convex mirror. Formation of image in a concave and convex mirror. First, rules for formation of image in these mirrors. Rules for formation of image. In spherical mirrors. There are three rules. First one is, in case of a convex mirror, this is pole, center of curvature, focus. If a light ray incident parallel to the principal axis, then what will happen? It will pass through the focus. And in case of a convex mirror, this is center of curvature, focus and pole, light ray incident on the convex mirror. What happens? If it is parallel, then what happens? It diverges from the focus. So this is the first rule. Light ray coming parallel to the principal axis passes through the focus for a concave mirror and seem to diverge from the focus for a convex mirror. जो पैरेलल आएगा वो फोकस में जाएगा या फोकस से डाइवर्ज होता हुआ दिखेगा. This is first rule. Second rule is just opposite of this, just opposite. जो पैरेलल आएगा वो फोकस से जाएगा, जो फोकस से आएगा वो पैरेलल हो जाएगा. This is concave mirror. Pole, center of curvature, focus. The light ray passes through the focus. After reflection, become parallel to the principal axis. In this case, in case of convex mirror, center of curvature, focus, pole. देखिए, coming parallel, diverge from the focus. Light ray coming towards focus, just opposite. Light ray coming towards the focus, became parallel. For this rule, the light ray passing through the focus of a concave mirror become parallel to the principal axis after reflection. And for convex mirror, what happens? Light ray coming toward the focus after reflection from the convex mirror become parallel to the principal axis. So these are the two rules. Come to the third rule. Third rule is the light ray passing through the center of curvature retrace the same path. In case of convex mirror also, okay, the light ray retrace the same path. The light ray passes through the center of curvature. In case of concave mirror, retrace the same path. Similarly, the light ray coming toward the center of curvature retraces the same path in case of convex mirror. Now, why does the light ray retrace the same path? We have already discussed. In case of a spherical mirror, this radius, that means the line joining from the center of curvature to the point of incidence, is normal. Itself is the normal. So here, as it is a normal, so here angle of incidence is 0 degree, angle of reflection is also 0 degree. The same thing happens here. This is the normal. That's why both angle of incidence and angle of reflections are 0 degree. So these are the three rules. Remember, जो पैरेलल आएगा वो फोकस में जाएगा, जो फोकस में आएगा वो पैरेलल हो जाएगा, जो पैरेलल आएगा वो फोकस से जाएगा, जो फोकस में आएगा वो पैरेलल हो जाएगा. वेरी सिंपल. और जो सेंटर ऑफ कर्वेचर में जाएगा वो उसी रास्ता में वापस आएगा. So there are three rules. The light ray coming parallel to the principal axis for a concave mirror passes through the focus, and for convex mirror seem to diverge from the focus. The light ray passes through the focus, become parallel to the principal axis for a concave mirror, and the light ray coming toward the focus become parallel to the principal axis after reflection from a convex surface. And in this case, they retrace the same path. So these are the rules. Okay. To get the position, for the formation of image by the ray diagram, you have to draw at least two ray diagrams, at least two rays you have to take. Then only you can find the position of the image. Now come to formation of image in a concave mirror. Formation of image in a concave mirror. Formation of image in a concave mirror. First is when object is at infinity. So suppose this is a concave mirror. This is pole, this is center of curvature, the midpoint is the focus. As the light ray is at infinity, so light ray coming from infinity are parallel. Let they are parallel to the principal axis. So what will happen? They will meet at the focus. So here image is formed at the focus. Okay, so what are the position, nature and size of the image formed? Position is at F, nature, real and inverted. Why real and inverted? Because the light ray actually meet at the focus. It is real and inverted. Size, highly diminished. Highly diminished means very, very small. Highly diminished means very, very small. So this is in case of a concave mirror. You may ask, what will happen if the light ray parallel but not to the principal axis? Yes, in this case, if the light rays come parallel to the principal axis, but if the light ray come parallel but not the principal axis, then they also meet at a point. The image will form here. It is just below the what? Focus. It is just along the, actually it lies in the focal plane. It is focal plane. The image must form on that same plane. Now, come to second case. When object is placed beyond C. Object is placed beyond C. C is also written as twice F. Here F is the point. Okay, 2F is the point only. So object is placed beyond C or 2F. Look at here. This is a concave mirror. This is pole, center of curvature, focus. This is the object. This is A, this is B. The object is placed beyond C. So let us take two rays. You may take any two rays. The light ray coming parallel to the principal axis, this is one ray. What will happen? It will pass through the focus. Okay? Another light ray light ray passing through the focus. What will happen? Parallel to the principal axis. So this is the image. Look at here. Why arrow mark is here? Why this is A dash? Because the light rays from A meet at this point. That's why this is image of A. What happens about B? The light ray from B, it will pass and return back. That's why the image of B will form here. Okay. So this is image A dash B dash. What is position, nature and the image form? Position is what? It is in between C and F. The image is formed between C and F. The nature, real and inverted. Size, diminished. Diminished means small size of it. You can verify. Here the size of the image is smaller than the object. Okay. So we are taking the object closer and closer to mirror. Initially it was at infinity, now it is beyond what? C. Now it will be at C. Then we will take in between C and F. Then at F. Then between F and P. So remember this diagram because it is very important. Okay. Try to understand and practice it. Third position is when the object lies at C. We can verify in practical classes. You can verify this the formation of the image, nature of the image, size. Okay. Come to third point. Third is. Before going to third point, here it will be better to draw this. Third is when object lies at C. Pole, center of curvature, midpoint is the focus. Object is at C. The object is AB. Light ray coming from A. Passes through the focus. Light ray passes through the focus. It is forms exactly at the same position. The light ray coming parallel to the principal axis passes through the focus. The light ray passes through the focus, become parallel to the principal axis. So these light rays meet at the point at C. So what is position? Position of the image is at C. Nature, real and inverted. Size is same size. You can see the size of the object and size of the image are equal. Come to the fourth one. Fourth one is when object lies between C and F. Okay. Very simple. Take these two rays. Very simple. The light ray coming parallel to the principal axis passes through focus. The light ray passes through the focus. So look at here. The light ray coming from this object AB. the image from here. Light ray from A coming parallel to the principal axis passes through the focus. The light ray passes through the passing through the focus. What happens? It became parallel to the principal axis. So here image is formed. So what is the position of the image? It is beyond C and real and inverted. And what is the size? You can compare the size of the object and size of the image. It is magnified. Okay, it is magnified. Now, how can you draw this diagram? In this case, especially, you have to take the proper distance of separation. Then only you can find the exact image. So, how can you draw the diagram? Okay, so let us show an example. This is up to 4, and there are two other cases. Okay. So let me finish these 6 cases, then I will explain you how can you draw the diagram. Fifth one is object lies at F. So this is concave mirror, this is pole, center of curvature and focus, object is at focus. Similarly, take 2 rays. The light ray coming parallel to the principal axis passes through the focus. अब क्या करेंगे? Second वाला ले नहीं पाए. We cannot take the light ray passing through the focus. So it is better to take this light ray. Light ray coming through the center of curvature. Retrace the path. That's why it will pass in this way. So you can see they are parallel. They will meet at infinity. That's why image is at infinity, real and inverted. Then it is highly magnified. So, simply when the object is at infinity, image is at focus. When the object is at focus, image is at infinity. When object is between C and F, image is formed beyond C. And when object lies beyond C, the image is in between C and F. They are interconvertible. Okay. And if the image is formed beyond C, then it is magnified. Here it is magnified, it is highly magnified. What happens if the object lies between F and P? Look at it. This is concave mirror, pole, center of curvature, focus. Let the object lies here. AB, the object lies between F and P. Now, let us take 2 rays. Light ray coming parallel to the principal axis. It will pass through this. Light ray through the center of curvature. Look at here, they are moving away from each other. The distance of separation gradually increases, they never meet here. So if we produce them backwardly, this is A dash, B dash. So here white is dotted, look at here, they do not meet actually. They meet only when they produce in backward direction. That means these light rays seem to come from this. So if you see in the mirror, you can find the image. The image is virtual and erect. Now it is virtual and erect. Where the image is formed? Behind the mirror. In other way, it is along opposite side of the object. Object is in front of the mirror and image is behind the mirror. And obviously it is magnified image. So look at here, only in case of the object lies between pole and the focus, the image is virtual and erect. Otherwise, in other cases, the images are real and inverted. Okay. So let us draw this diagram. What happens when the object lies between F and P? Same diagram. Let us take a scale. It is better to taking 3 centimeter distance of separation. Here I am taking some bigger unit. Okay, like this. This is a concave mirror. This is pole, focus and center of curvature. One point is taken as pole. Look at here, the distance of separation between C and F is also equal to the distance of separation between F and P. So now the object is placed in between C and F. P and F. Let this is the object AB. You have to take 2 rays. The light ray coming parallel to the principal axis. Light ray coming parallel to the principal axis. What happens? It passes through the focus. It passes through the focus. Okay. So you may have confusion that although the object is in front of it, how does the light ray can pass through it? It's the ray diagram. It doesn't mean that there is only one ray. No, there are so many rays, but all the light rays coming from the point A, they pass through this point. They will meet at a point. Look at here. Now come to second one. You can clearly observe they are diverging, they are moving away from each other. So what will happen? They have to produce in backward direction. They have to produce in backward direction. Now this is the position of the image. Look at here. So in this way you can draw the diagram. Remember, this distance must be equal. This and this distance must be equal. This distance of separation between CF and AP they must be equal. Now, formation of image in a convex mirror. In convex mirror, there are only 2 positions, either it is at infinity or in other position, because in case of a convex mirror, center of curvature and focus lies behind it. That's why we cannot say the object is between P and F, F and C. If the object is behind it, no image is formed. So one is taken at infinity. When you take at infinity, they will meet at the focus. But for any other position, look at here. The light ray coming parallel to the principal axis. they will diverge. They seem to come from focus. Now, light ray coming towards center of curvature, they will retrace path. You can see they meet here. That's why virtual images form A dash B dash. So, in case of a convex mirror, the image is virtual and erect, and it is what? It is in between P and F. Position, nature, size diminished. So in case of convex mirror, the image is always diminished. A diminished image is formed. Okay, so you can verify the nature of the image. Let us see the image formed in a. Here this is the screen. This board is screen, which is a real image is formed on the screen. This is the object, the flame is the object. This is concave mirror. You can see the image. Okay. If the object comes closer, you can see the image is magnifying. Larger image. Come closer, larger image. Okay, and if it's taken away, the image comes closer. In this way, you can verify the formation of image. Look at here. Okay. Okay, thank you.